These are the Section 7-1 notes. You're going to need your textbooks open to page 401, and I would suggest having a calculator with you as well. We're going to start talking about things called monomials and polynomials, and today we're just going to start talking about multiplying monomials. And a monomial is a number, a variable, or a product of a number and a variable, and they often have exponents. So a monomial is a number, a variable, or the product of one or more let's go with variables with non-negative exponents. We're going to say integer exponents so that we don't get any fractions or decimals. Okay. Now, when I say product, product means multiplication. No addition, no subtraction, and no division. So, an expression that involves division by a variable is not a monomial. So if I have 13 times a divided by b, that's not a monomial because it has division. Now, if I have something like 13a, that is a monomial. Or if I have 13ab, that's a monomial. You can also have, let's see, we're going to leave that for later. So anyway, a constant is the next term that we're worried about. A constant is a monomial that is a real number. So basically it's just a number. We could say 4. We could say 1/2. We could say 6. Anything positive or negative, we could say negative 100. All of those are fine. That's a constant. We can also talk about the different kinds of monomials. We have 3x. Now notice that there is no exponent with the x. That means that when I graph it, I will get a line, so it's called a linear expression. We also have like 2x squared, where the exponent is not 1. That's going to give me a parabola when I graph it, so it's non-linear. So it does not make a line, but it's still a monomial. Go ahead and turn the page. We're going to go ahead and take a look at some of these and see if we can determine if they are or are not monomials. Okay, 10 is a constant, so yes, it's a monomial. F plus 24 has addition, so it is not a monomial. H squared has multiplication and has an exponent, which is fine, and it's non-negative. So, yes. Okay, I want you to try the rest of these on your own. I'm going to keep going, so you should pause the video and then come back and check your answers. J is by itself, so there's no multiplication, addition, or anything, so yes. This has addition, no. This has a bunch of multiplication, but there's nothing else, so yes, it's just fine. This one has division by 2, which is like saying 1/2 times x, y, z squared. That is okay. So the only thing that cannot be in the denominator is another variable. You can, however, have a number, so yes. This is being divided by a variable, so no, this is not a monomial. We've been talking about bases, powers, and exponents every year now since we started looking at algebra. And remember this little model. The number right here is an exponent. The big number is called the base, and the whole thing is called a power. Now, when I take a look at this, I have 3 to the 4th power. Basically, that means 3 times itself, where you see 3 4 times. So 3 times 3 times 3 times 3. There's 4 factors. And that actually gives me 9 times 9, which is 81. Go ahead and turn the page. By applying the definition of a power, you can find the product of powers. And that seems like a lot to take in, but if you turn your textbooks to page 402, we're going to write in that key concept. And product of powers says to multiply two powers that have the same base, just add their exponents. I have that written here where it says the words of that definition: to multiply two powers that have the same base, add their exponent. So the big number on the bottom, if it is the same and you are multiplying it, you just take their exponents and add them. I'm going to show you why that works out the way it does. Let's say I have 2 squared plus 2, or times, 2 to the 4th. If I rewrite that, I'm going to take 2 squared, which is just 2 times 2, times 2 to the 4th, which is just 2 times 2 times 2 times 2. Now, notice all of these are the same. They have the same base. So I could rewrite it as 2, and I'm multiplying it. I see it 6 times, so to the 6th power, which if I take a look, that is just the exponent 2 plus the exponent 4. So I get 2 to the 6th power. Now come down here. If I have 4 to the 3rd times 4 squared, they have the same base of 4, I'm just going to get 4 to the 5th power. So I don't have to write it out every time, I just add them. That's only true if the base is the same. Now let's come down here. I have 6n cubed times 2n to the 7th. The 6 and the 2 aren't the same, but they're actually just coefficients to n to the 3rd and n to the 7th. So I'm going to pull them out front. I'm going to say this is the same thing as 6 times 2. I can do that because of the commutative property, times n cubed times n to the 7th power. So I can combine these. I'm going to get 12. Now n to the 3rd times n to the 7th is just n to the 10th power. I just add them. And that would be my answer. So let's go down to the next one. I want you to try this one on your own, and we'll do this next one together. Pause the video, try it, and then come back. Now I have 3 as a coefficient. I'm going to pull it out front. I'm going to say p times p to the 3rd, I can do that because of the commutative property, times t cubed times t to the 4th. And now I'm rewriting them so that they sit next to each other so that when I go to add them, I don't get confused. So I have 3 times p to the 4th. The reason it's p to the 4th is because if I just see p by itself, it's actually just p to the 1st power, and 1 plus 3 gives me 4. Then I have t to the 7th. Alright, let's take a look at the next one. I have -4 and -6 as coefficients. I'm going to move them out front. Now, they're both negative, so I'm going to write them in parentheses so that I don't get confused by the negative signs. Then I have r to the 1st power, r to the 5th, x squared, t cubed, and t to the 1st. So now that I've rewritten it using the commutative property where all of the variables are next to each other if they're the same, I can go ahead and do the multiplication and addition of exponents. So -4 times -6 is 24. Then I have r to the 1st plus 5, which is r to the 6th, x to the 4th, t to the 4th. And that is how we simplify those expressions. Go ahead and turn to the next page. We can also use the same rule to find the power of a power. And what that means is, so I want you to take a look down on page 402. Do you see power of a power? We would say if we have 3 squared to the 4th power, notice how 3 squared is on the inside of these parentheses and then the 4th power is on the outside. I'm going to rewrite it where this is the base, this is the exponent, and this whole thing is the power. So they're saying I'm going to rewrite this as 3 squared times 3 squared times 3 squared times 3 squared, because we said 3 squared was my base, and I should see it 4 times as a factor. Now, these have the same base. I just will go ahead and add up their exponents. So I get 3, 2 plus 2 plus 2 plus 2 gives me 8. So I get 3 to the 8th power. Down here, let's try this one. I have r to the 4th times r to the 4th times r to the 4th. My exponent is 3, so I should see it as a factor 3 times. Same base, and I'm going to go ahead and just add my exponents, so I get r to the 12th power. Okay, we're talking about power of a power, which is the key concept on the bottom of page 402. The words are to find the power of a power, multiply the exponents. And what it's saying is r to the fourth is a power in itself because it has a base and an exponent. We're going to add another exponent in there and make it another power. So this is the power of this power. So when you see power of a power, it's kind of confusing, but that's what they're talking about. In symbols, it means you just take a to the m power, and then you can, to the p power, you just take m times p. Notice, if I take 4 times 3, I get the 12 that I end up with. If I take 2 times 4, I get that 8 that I end up with. We do just add them, but instead of having to write them out each time, just multiply the exponents. So down here, I have b to the third to the 5th power. So I get b to the 15th. And I have g to the 6th to the 7th power, which is g to the 42nd power. Now, on the first page, we only had powers where they had one exponent and one base. That's when you added the exponents. On this page, we are talking about powers of powers where you're going to have an entire power, including a base and an exponent, and then another exponent. That's when you start multiplying the exponents. It's going to take a little bit of practice to get those two things straight, but that's something you're going to need to know. So practice as much as you can. Say it out loud when you're doing your homework so that you remember power of a power, I multiply. And normal powers, I just add. So turn to the next page. Here's some examples. Notice I have another power. So I have the first one. So here's a power. I have a power of a power. And then I have another one. So I have a power of a power of a power. Same thing. I just multiply. So I'm going to have 2 as my base. And then 3 times 2 gives me 6 to the 4th power. Just go ahead and multiply. And I get 2 to the 24th power. I want you to try the next two on your own. Pause the video and come back when you're ready. So my base is 2, and I'm taking 2 times 2, which gives me to the 4th power again, because that's what's on the outside, so I get 2 to the 16th power. The bottom one, I have 3 as my base. 2 times 3 gives me 6. To the 2nd power, that's what's on the outside, gives me 3 to the 12th power. Go ahead and turn the page. Now, we might also see something called a power of a product. This is on page 403. The words state, to find the power of a product, find the power of each factor and multiply. So, if I have two terms on the inside, well, I shouldn't say terms. If I have two numbers or two variables to the same exponent, so see how the exponent is outside the parentheses, I just distribute that exponent to each piece and leave it like that. So AB to the mth power is actually just A to the mth power, B to the mth power. So look down here. I have negative 2xy cubed to the 5th power. So I'm going to take that 5 and I'm going to give it to each piece. I'm going to rewrite this as negative 2. Now since it's negative, I'm going to go ahead and write it in parentheses to the 5th power times x to the 5th power times y cubed. It already has an exponent, so I'm going to write it in parentheses again to the 5th power. Then, using the rules that I already know, I'm going to go ahead and simplify that. I'm actually going to go ahead and find out what negative 2 to the 5th power is as a number. This is where that calculator comes in, because I don't know that. But for when you're typing these things into your calculator, make sure you're putting the numbers inside parentheses, especially if they're negative, because that will change your answer. So I'm going to put parenthesis, negative 2, end parenthesis, caret, that gives you the power of 5. I get negative 32. So I get negative 32. X to the 5th is already done. Y to the 3rd to the 5th. So it's actually just y to the 15th power. And we're done. Go ahead and try these next two on your own. Pause the video and come back to check your answers when you're finished. I have 3xy squared to the 2nd power. I'm going to distribute that 2 to each piece. And I get 3 squared times x squared times y squared squared. 3 squared is 9, x squared is done, and then I have y squared squared, which is just y to the 4th. On the next one, I take the 4 and distribute it to each piece. So I have 5 to the 4th, a to the 3rd to the 4th, and b to the 5th to the 4th. 5 to the 4th power is 625. A to the 3rd to the 4th is a to the 12th, and b to the 5th to the 4th is b to the 20th power. Go ahead and turn the page. Now, we've learned about 3 different things. We've learned about products of powers, powers of powers, and powers of products. Those are 3 different rules that you can combine to simplify expressions. So, to simplify a monomial expression, each variable base appears exactly once. So I shouldn't see a set to the 7th power times a to the 3rd power. I would have to combine those things in order to be finished. There are no powers of powers, which means I don't see anything like b to the 3rd squared. That can't happen. I would go ahead and simplify that using my rules. And all fractions are in simplest form. So if you get 2 to the 4th, simplify it to 1/2. Okay? Let's go ahead and take a try. So I have 3x y to the 4th squared times negative 2y squared to the 6th power. We're going to use the order of operations and deal with each set of these parentheses alone and then combine them. So I'm going to take the first section and I'm going to make it 3 squared times x squared times y to the 4th squared. I just distributed that 2 to each piece. So I get 9x squared y to the 8th. All of that times, and then I simplify this. I have negative 2y squared to the 3rd power. Okay, I'm going to distribute that 2 to each of these pieces. So I get negative 2 squared y squared all to the 3rd power. So I get negative 2 times negative 2, which gives me positive 4 y squared to the 3rd power. Distribute that 3 to each piece. 4 to the 3rd times y to the 6th, because I just take y squared to the 3rd power, so I multiply these two. 4 to the 3rd power is 64 y to the 6th. So I have my 2 pieces. I'm going to come over here and finish it. I have 9x squared y to the 8th times 64 y to the 6th power. And I'm going to rewrite them. Remember how we did it on the first page. I'm going to bring the 9 times 64 out front. I'm going to bring the x squared down here. Now there is no x's in this one, so that one's finished. Then I have y to the 8th times y to the 6th. 9 times 64 is 576. X squared is by itself, so it's finished. Then I have y to the 8th times y to the 6th. And remember, if they have the same base, I just add their exponents. So y to the 14th. Go ahead and turn the page. So on this one, I'm just going to start distributing. I have 3, I take it to the 1/2, to the a squared, and to the b squared. So I get 1/2 cubed times a to the 6th times b to the 6th times, and then I'm going to distribute the 2 inside of the parentheses first, times negative 4 squared b squared all squared. I'm not finished simplifying on this right-hand side, so I'm going to distribute that first. This negative 4 squared is actually positive 16, so distribute that 2. So I get, I'm going to bring this all down here. I'm going to say 1/2 cubed is actually 1/8. A to the 6th, b to the 6th, times 16 squared, b squared squared is just b to the 4th. And so I can take this and I'm going to say 16 squared is 256. So I have 1/8 a to the 6th, b to the 6th, times 256 b to the 4th. So I'm going to rewrite this. I'm going to say 1/8 times 256 times a to the 6th times b to the 6th times b to the 4th. If that seems like a lot, I pulled the 1/8 and the 256 together. This is the only a, so it stands alone, and then I put the 2 b's together so I can start combining them. 256 times 1/8 is actually just the same thing as 256 divided by 8, which is 32. A to the 6th, b to the 10th. A to the 6th is alone, so it just stays the same. And b to the 6th times b to the 4th, and remember I add them and I get b to the 10th. That's a lot to take in, so make sure you're paying attention to the different rules as you do them. I want you to go ahead and try the next 2 pages on your own. There's 3 examples that I want you to try on your own. They get big, but don't be intimidated because it's the exact same rules no matter how small or big they get. Pause the video, try them in pencil, come back and check your answers, and if you miss them, follow along with what I do and see if you can catch your mistake. So, first thing I'm going to do is distribute the 2 to each of these, and I get 5 squared, which is just 25. X squared is x to the 4th. Y to the 1st power squared is just y squared. Times, distribute that 3, I get 2 to the 3rd power, which is 8. X to the 1st power times 3 is x to the 3rd. Y to the 9th power, and then z to the 3rd power. Over here, there is no exponent on the outside, so I just write it as is. Okay? Now I'm going to start pulling out things that look alike and putting them next to each other. So I have 25 times 8 times 4 times x to the 4th times x to the 3rd times x to the 1st, x to the 4th, x to the 3rd, x to the 1st, times y squared times y to the 9th times y to the 1st. I don't have any more over here, so I have z cubed times z to the 1st. Then I can start combining them. 25 times 8 is 200 times 4 gives me 800. X to the 4th times x to the 3rd is x to the 7th. Oh, I'm sorry, x to the 4th times x to the 3rd to the x to the 1st is 8. Sorry. Then I have y squared times y to the 9th times y to the 1st, which gives me y to the 12th power. And then z cubed times z to the 1st is z to the 4th power. So notice how that kind of got bigger, but then we were able to simplify it into something easier to use. All right, on this last one, same thing, distribute that 2. Negative 3 squared is positive 9. D squared is d to the 4th. F to the 3rd squared is f to the 6th. G to the 1st squared is g squared. Times, now this one's going to take one more step because I have 2 exponents to deal with. So I'm going to deal with the first one. And negative 3 to the 3rd power is negative 27. D to the 6th, f to the 3rd, and then this whole thing squared. I have to finish dealing with this before I can combine the 2. So I'm going to just rewrite this one as it is. 9d to the 4th, f to the 6th, g squared, times positive 54, because negative 27 squared is positive 54. D to the 6th squared is d to the 12th. F to the 3rd squared is f to the 6th. Now I can combine them. I'm going to say d times 54. Oh, I'm really sorry. That's 9. 9 times 54 times d to the 4th times d to the 12th times f to the 6th times f to the 6th times g squared. 9 times 54 gives me 486. D to the 4th times d to the 12th is d to the 16th. F to the 6th gives me f to the 12th, and then g squared. Okay, now this next one was really long, but remember that it doesn't matter how big or small they are, you use the same rules. So go ahead and apply your square. So I get 9a squared b to the 4th c squared times positive 4 a to the 4th b to the 8th times a to the 12th c to the 6th times a to the 4th b to the 8th c to the 10th times 2 cubed is 8, a to the 9th, b to the 6th, c to the 12th. That was a lot. There still is a lot to deal with, but we're going to start simplifying it, and you're going to see how this huge thing is going to become something really compact. So I'm going to take the coefficients, and I'm going to do all the coefficients in green. So I'm going to say 9 times 4 times, now this didn't have one, neither does this. This one does, 8. Then I'm going to take all of the a's and I'm going to do them in blue. A squared times a to the 4th times a to the 12th times a to the 4th times a to the 9th. Then I'm going to take all of the b's and I'm going to do them in pink, times b to the 4th times b to the 8th times b to the 8th, this one did not have a b, times b to the 6th. And if I can find another color really quickly, I'll do c in another color as well. Just one second. I'm going to do all of the c's in purple. So I have times c squared times c to the 6th times c to the 10th times c to the 12th. Okay? Now, that's a lot, but we're going to start combining them now. 9 times 4 times 8 gives me 288. A squared, a fourth, a to the 12th, a to the 4th, a to the 9th. We just add them. So 2 plus 4 gives me 6, plus 12 gives me 18, plus 4 gives me 22, plus 9 gives me 31. So a to the 31st power. I'm going to add them in my calculator to double check that math. I get 31. Okay, so I've dealt with all these. I've dealt with these. Let's deal with these next. B to the 4th, B to the 8th, B to the 8th, B to the 6th. Add them together. 12, 20, 26. B to the 26th power. Now over here I have the c's. C to the squared, C to the 6th, C to the 10th, C to the 12th. Add them up. I get 8, 18, 30. Okay? So I took this huge thing, kind of had to make it a little bit bigger, and then I was able to compress it into one small 288, a to the 31st, b to the 26th, c to the 30th. So it's way simpler, and it means the exact same thing as all of this. So I know that that's a lot to take in. Those rules are really tricky to remember. Over time, they will get easier, and it will just become second nature to you. If you're having a hard time grasping them, go ahead. The textbook does a really great job with the definitions and examples of each of these, and you can try some of the examples at the end or try some of them in the actual textbook homework. This is the end of the notes. We'll go over any questions you have, and we'll do a few examples in class on Monday. But in the meantime, just maybe read through this again and see if you have any questions for me about the actual notes. Otherwise, have a great weekend.